Hi everyone, welcome to Virtual School Physics is Fun. This is Puan Liao speaking again. Alright, now today Puan Liao is going to teach you about resultant force, which is also called net force. What is resultant force or net force? When an object is acted by more than one force, let's say two or three forces acting on an object, so the total force that is acting on the object is the sum of all the vectors of the force that acts on it. So this is called resultant force or net force. Let's look at some examples. Now, if the two forces or all the forces that act on the object is parallel, okay, and for example, this trolley is acted by 60 Newton and 30 Newton, and these two forces are in the same direction. They are parallel and also in the same direction. So because force is a vector quantity, so it has got magnitude and direction. Okay, so because these two are in the same direction, therefore we just simply add up. Yeah, we just easily add up the magnitude of the two forces. So the net force will be 60 plus 30 equivalent to 90 Newton and 90 Newton to the right. Okay. Now, what if the forces acting on an object is not of the same direction but opposite directions? For example, 30 Newton to the right, 10 Newton to the left. They are of opposite direction. So because force is a vector quantity, so direction is very important. Okay, so direction, like normally we will take the bigger quantity force as the positive direction. So the other one, which is of opposite direction, will be negative. Okay, so the net force will be equals to 30 Newton plus the negative of the 10 Newton because 10 Newton is of opposite direction. Yeah, negative of the 10 Newton. So meaning to say is equivalent to 20 Newton, and this 20 Newton is positive, and positive is to the right, isn't it? Positive, yeah, 30 Newton is positive direction, so 20 Newton is also positive, therefore it is to the right. Now, if the forces acting on an object is not parallel, but instead it is perpendicular, so how should we find the net force? Okay, let's take this example. So the object is acted by two forces, which is 3 Newton and 4 Newton, and they are perpendicular to one another. So these two forces that is acting on the object can be taken as one force acting on it, followed by another force. Okay, we push the object with 3 Newton first, then followed by 4 Newton. Yeah, so it's equivalent to these two forces acting on it at the same time. So 3 Newton, so we push the object to the right with 3 Newton, followed by 4 Newton upwards. So where does the object go to? Okay, as a result of this, where does the object move to? So the object will move this direction, this manner. Okay, so because the resultant force, the net force is this. Now, how to find this net force? Because force is a vector quantity, so these 3 Newton force and the 4 Newton force, they are not of the same direction. They are of different direction, but perpendicular to one another. So we cannot just add up the magnitude of these 3 and 4. We cannot just add them up and say that the net force is 3 plus 4, 7 Newton, because they are not in the same direction. Okay, so but because they are perpendicular to one another, so we can use Pythagoras theorem to find the net force. Alright, so we use Pythagoras theorem to calculate the net force. What about the direction? So the direction, we can take theta as the direction of the net force, and we use a protractor to, we can calculate theta by using trigonometry. Okay, so we use tangent. So tangent theta equals to the opposite over adjacent. So it's 4 over 3 and we find theta. Right? So we can state that the net force is 5 Newton and at the angle of 53.13 degree from the 3 Newton force. Okay. Now the third case is when the two forces acting on the object is neither parallel nor perpendicular. Yeah, they are not perpendicular, they are not parallel. So how? So for this case, it will be easier if we go by drawing. Yeah, we find the net force through drawing. Okay, so we can draw triangle of forces or we can draw parallelogram of forces. Now, if you are given an object acted by two forces, 70 Newton and 55 Newton at an angle of 74 degree. And these two forces, this diagram is not drawn in scale. So if we have to find the resultant force, so we will need to draw, yeah, if we want to solve it through drawing method, so we need to draw a diagram. Okay, so we choose a scale, we choose a suitable scale, and then we draw. Okay, so we draw 55 Newton. Let's say if we choose a scale of 1 cm to 10 Newton, so this will be 5.5 cm. Alright, now continue with 70 Newton. Yeah, continue with 70 Newton after acting 55 Newton. So because this angle between the two forces is 74 degree, so to draw the 70 Newton, so this is 74. Therefore, 180 minus 74 gives us 106. So we use a protractor, we measure 106 degree and we draw this line BC. And this BC line will represent the 70 Newton. So how long should BC be? So use the scale, so 70 Newton, so it will be 7 cm. Right? And then, so that means to say we have drawn 55 Newton acting on the object, followed by 70 Newton. Okay, so what is the resultant force? Very clearly, AC. Join up AC, okay, to get a triangle of forces, right? So AC is the net force. Therefore, we get a triangle ABC, which is called triangle of forces. So we use a ruler, measure the length of AC, and using the scale to calculate the net force. Alright, and using protractor, measure the angle theta, which is the angle of the net force with respect to the 55 Newton force. Okay, now lastly, if the forces acting on an object is already drawn in scale, okay, so we are asked to complete the diagram, complete this diagram of forces to get the net force. So we don't have to redraw everything like what we did just now for the triangle of forces. We just draw on this diagram. Yeah, so we complete the diagram by drawing parallelogram. So how to draw parallelogram? Of course, we need a pair of compasses. Okay, so by using compasses, measure the length of AB and then draw an arc and measure the length of AD, draw another arc. So we get the point C. Join up, okay, join up to C to get a parallelogram, to complete the parallelogram. Okay, and the point of action is A. The object is at A, right? So from A, we draw the diagonal, okay, diagonal to C. Not this diagonal, from A, from A, this diagonal to C, and this is our net force. Okay, so by using the scale, we measure the length of AC and calculate from the scale the net force. And using protractor, measure the angle theta. Okay, and we can state that finally we can state that the net force is, for example, in this case 98 Newton and at an angle 44 degree from the 55 Newton force. Okay, all right, so these are the three cases to find resultant force. All right, so I hope you have understood what I have explained to you. Okay, so that's all for today's lesson. Watch out for more video on resolution of forces. Okay, thank you. I see you again. Bye.